All right, good morning. I'm Mohit. I'll be the course instructor. We have three sections for this course today. There's 4803, there's 8803, and there is a video section, a Q section. Ideally, that means there should be someone here from GTPE who's basically recording this session, but I'm not sure I see anyone here doing that. So what I'm doing is basically sharing this on Zoom and recording it. And that's why I have AirPods. It's not like I'm listening to music or anything on the side. It's basically there for a reason. Um, so with that, I think we can start this thing. Uh, this is probably the first class of the semester for most of you. I'm sure that at least I hope that none of you have taken like an 8 a.m. class in the early morning. If so, then it's your choice. So it's your decision to make that. This itself, I feel, is like an early class, but again, 9:30 is quite a fine time. So what we'll be doing this semester is fundamentals of machine learning. There's a nice, it reduces down to FunML, so that's a good way of putting it. But ideally, the entire the course is about fundamentals and applications of machine learning. So we'll go through some very basic, some logistics of the course today, as well as going through some like a simple introduction to what machine learning is and what you can expect throughout the course here. So let's start off by looking at what we're going to talk about today. There's going to be two things. The first one is going to be just about like the logistics, very boring stuff, but probably extremely important. We'll go through that first. And the second one is going to be a more technical way, a very umbrella overview of what AI is and what machine learning is and so forth. So it's going to be a very light class for today. From next week onwards is when we'll actually dig deeper into what machine learning is and what the kinds of machine learning is and what we're going to study through it. So first part is about syllabus, Canvas, Piazza, Collab tutorial, and the structure of the slides that we'll be using. So instead of using slides for this, I'd rather go through the syllabus. Now, I don't think I have published the Canvas course yet, so you have not been able to see the syllabus or the structure of it. I'll probably do it within the next couple of days. So we have been assigned two TAs, but there may be some issues. Maybe one of them may be replaced by some other person. So it's not very sure yet. So this is me up top. I'll be the course instructor. For now, we have Jorge and Lorraine, who will be the two TAs for this. But again, this is subject to change. We'll meet all Mondays and Wednesdays at this time from around 9:30 to about 10:45. There will be certain days where it will not be possible for me to lecture in person. In such cases, what we'll do is have a recorded slides, recorded video, or we can have an online session essentially through Zoom. And mostly it's because I'll be attending either some conferences, seminars. So these are the three confirmed dates that I will not be there. Jan 7th was yesterday. I was literally in the middle of the Pacific Ocean. And if you hear my voice is bad, it's because I took a red-eye flight back from there, and I landed in Atlanta at 6:30 a.m. So it's not that I'm not enthusiastic about the course. I am. I love machine learning. It's just that I am jet lagged. I am tired. So on Wednesday, you'll probably hear a better voice from me. But for now, it's because of that particular fact that the voice is very, tired. I also have a conference on Jan 22nd and Feb 21st. So these are the 2 days that we'll be missing class, or 90% we'll be missing class on those days. But again, I'll have either a video recording for that particular week, or we are going to have online session. Both of them are on the West Coast. So it should be fine to have like an online session on those days. So office hours as well, we'll decide it. I think I'll have around 2 hours per week. Both the TAs will also have around 2 hours per week. So that should give you sufficient coverage throughout the week to hopefully have a more balanced overview of what is happening, especially with the homeworks. There's no required textbook. The field of machine learning, the field of machine learning itself is not new. It's been there for a huge amount of time. It's just that the new revolution that has happened with deep learning is so new that it's almost impossible to have a good a textbook for the course itself. This one, deep learning from Goodfellow, Yasho Bengio, and Corwell, is actually probably one of the best resources out there to try to understand what deep learning is from a very basic perspective until the very end, which is the newest things that exist right now, which is the foundation models and self-supervised learning and so on. This is a very nice book that talks about all these things. If you're not just interested in deep learning, the second book here, which is a machine learning refined foundations, algorithms, and applications, is a very nice book that helps to understand the basics of machine learning. There's other textbooks as well, especially dealing with statistics. If anyone's interested, I can go through and I can list those books as well for you. But the most important part here is there's no required textbook for the course. The slides will be made available for everyone, and the slides should cover everything that is necessary. And within the slides itself, we'll have n number of references that is going to help you with the course itself. In terms of prerequisites, there are a couple of things that is required. So machine learning in general, deep learning in general, requires a certain level of mathematical understanding, specifically two things, which is linear algebra and probability. So if you're comfortable with these two things, then this is a good course for you to take. If not, then you have to do a substantial amount of reading through. So in this particular set of slides, I do have at the very end, there are a few slides on a review of probability and a review of linear algebra. It's a good idea to go through that. I don't think I'll be able to go through the review today, but for you all, when I post these slides online, it is a good idea to go through it just to see how comfortable you are looking at these mathematical concepts that exist. So that is in terms of just the math concepts of it. The next one is the programming concept, because that is also extremely important with respect to machine learning. So generally, we'll be using Python in all our homeworks. I'll talk about homeworks in a while, but essentially, when you look at the homeworks, you'll see that after the first and the second homework, it's mostly these kind of mini projects that you'll be doing. You'll be solving some kind of a simple machine learning problem within your homework itself, which basically means that you need to have a very good understanding of Python and how to use these resources. But this doesn't mean, of course, that you need to be experts in like data structures, algorithms, and all the computer science stuff. When I first started, I basically went through the tutorial, and even now, when I want to code, I just go on Stack Overflow and ask, how do I do this? How do I do that? So it's not very problematic. It's just that you should be able to have a basic knowledge of Python so that you'll be able to use them in homeworks and your projects and so on. So these are the prerequisites, just some basic understanding of math and a basic understanding of programming with Python. As I mentioned before, the objective is not just to understand the fundamentals of machine learning, it's also about the fundamentals and applications of machine learning. There's a couple of important things about academic honesty that we take very seriously in Georgia Tech. So this has to be something that you take note of. But this doesn't mean that we encourage group homeworks, for instance. So there's going to be about 7 homeworks. The number can become plus or minus 1 depending on the the number of weeks and how far we are progressing through the topics. But let's just take 7 as like the average number of homeworks that's going to be there. And this is going to be spread across like each homeworks. You'll probably have some homeworks you'll have just 1 week to complete it, but then there will be homeworks where you'll have 2.5 weeks to complete as well. And in every single homework, we encourage group discussions. You'll of course have to submit on your own. That is, you have to program and write code on your own and submit it. But just to have a discussion about the problem itself, how you would want to solve the problems and so on, it'll be very good to have these kind of group discussions that will be there. There'll be 2 midterm exams and 1 final exam. So there'll be 10 points for each of the 2 midterm exams, and there's going to be a 20 points for the last final exam. I'll talk a little bit about, maybe I'll start with this, the grading. So as I mentioned, there's going to be 3 sections. One section is an undergrad section. I believe it's around like 36 students who have registered last I checked, and there's grad section, which is about 32 students. And there's a third section, which is a grad section for video students. So for all undergrad students, it's going to be a 60 plus 40, where your homeworks will be counted for 60% and exams are going to be 40%. So that basically means that the 40% in exams is going to be divided as 10 plus 10 plus 20. So each midterm is worth 10, and then there's an exam that is worth 20 for undergrad students. For grad students, the same thing happens in exams as well. It's a 10 plus 10 plus 20. And you'll solve the same homeworks as the undergrad students, except that your assignments will be valued lesser. So instead of it being 60% for undergrads, as it was for undergrad students, grad students will have it for 40% essentially. You'll be solving the same homeworks, except at the very end, we'll do some kind of post-processing where we'll weigh it lesser for grad students than the undergrad students, because the remaining 20% will be taken up by something called your project. And I think I had something about the project somewhere. Apparently not really, but maybe when I posted, you could see. So ideally what the final thing here, I didn't have it as a boldface. So the project that you'll be doing is going to be on some kind of a state-of-the-art machine learning module that we'll be using, probably a deep learning module. And we'll have a more a full description of what the project is within the first 2 weeks, probably after the first 2 weeks, once you get settled in and once you're done with homework number 1. But essentially, it is something that you can work on throughout the semester. And at the end of the day, you'll have to submit this kind of a 4 or a 6-page IEEE paper kind of a report. And that's also what we will be expecting essentially from grad students, that you will be able to take the stuff that you have learned throughout the course and apply it and have this kind of a paper, a 4 to 6-page paper that you can write on this. Again, this is something that is going to be done in groups as well. And each group will have one report essentially. So we'll have a bigger discussion of what the project is probably in 2 weeks time. But that is going to be worth about 20% of your grade. And we'll be using the standard definitions of grading here. A is going to be between 90 and 100, B is 80, 89, C is 70, 79. Of course, at the very end, maybe we can change a little bit about the cutoffs. We can, it's not going to be a completely curved thing, but we can change that cutoffs a little bit just to push up a few here and there. But we can think of this as A, B, C, D, E, A, B, C, D, and F. This is usually what is there in all courses. So we're just using the exact same thing in this particular course as well. What else? What else? I think I spoke about the exams, assignments. Assignments is the same as the homeworks. So again, there's going to be analytical part and hands-on part. Like I can tell you that in homework 1, you'll solve a little bit about like matrix theory. There's going to be a little bit about linear algebra, which is where the analytical part comes in. And there's going to be some kind of a Python code that you would have to do, which is where the hands-on part comes in. Again, you need to have some background in Python, and we'll be using Google's Colab essentially for doing this. It's because that is the easiest way for the TAs to help you. If you have worked with machine learning and deep learning before, there's a lot of packages out there. There's scikit-learn, there's NumPy, there's PyTorch as the environment, and each of them has its own kind of environment that you would have to do. And it's really hard if you come to us for asking questions, hey, this is not working, can you help me debug? It'll be really hard for us to help you in that sense if you're using your own environments, if you're using your own libraries. So we have these kind of standard set of libraries that we want you to use and the standard environment that we want you to use. And this is something that a lot of people use as well. Google Colab is probably a very good starter environment for trying to do some kind of deep learning or machine learning algorithms. probably at the end of this week or in the beginning of next week, we'll have a survey as to how comfortable everyone is in Python and Colab and stuff like that. And based on the results of that survey, maybe we'll have this kind of a tutorial session. One of the TAs will have a tutorial session for these environment. That is something that we'll take a look at later next week. But for now, just know that there is a plan in terms of for each homework, because there's a coding component involved, we need to have this standardized environment for everyone. And currently, it is going to be Google Colab. Finally, I think there's also somewhere in March, I believe there are talks right now of giving these kind of clusters to students, where to everyone basically in order to run your codes. Because these days, if you're looking at deep learning algorithms, even the GPUs that you're running, even if you have the best laptops, the GPUs you're running, it's not always easy to run these modules, to train these modules. So ECE is currently setting up a cluster, and this course is currently assigned to be one of the classes where you'll be able to use that cluster. But again, there's a lot of logistics involved. There's a lot of things that are happening in the background. So maybe this is possible in March, but we're not very sure. So based on that, we may change a little bit regarding what the homeworks are and the project is going to be as well. But more information on that probably in the next month, somewhere in February, we can have a larger discussion if that pans out. Anything else? Canvas. Yes, I'll be publishing Canvas within the next couple of days. I'll speak with the TAs within the next, I think we have it scheduled for tomorrow. And once that is done, I'll publish everything within the Canvas. And this is very important. I want to push Piazza as much as possible. Hopefully, a lot of you have already used Piazza in your other courses as well. Let's try to keep like emails to a minimum, either to me or the TAs. But if you do want to send emails, please add a header and square brackets, add 4803 or 8803, because if I miss it on one particular day, it's very hard for me to go back and find those emails the next day and so on. So if you put those headers, I can just search those emails and find it. But again, extreme cases, please, emergency cases, use the emails. Otherwise, Piazza is probably the best way to contact. So both the TAs are going to be there. I'll also be there. We'll be monitoring this and hopefully giving you solutions there. Again, once I have the Canvas set up, we'll have Piazza within the Canvas integrated as well. So you should be able to see that within the Canvas page. Assignment submissions will be on Canvas. There'll be detailed more details basically within the homework itself, how we'll be submitting it, and so on. So attendance, Institute has a policy about attendance. It's very important. We encourage attendance as much as possible. We also have this kind of a verification of participation that is required. It's usually required till now. And the way we usually have is the survey, like I mentioned, right? So we'll have a survey in the next week where we'll ask, how comfortable are you with Python? How comfortable are you with Colab and stuff like that? And we'll use the answers to that as this kind of a verification of participation. We'll also maybe use like turning point within the lectures itself, somewhere from next week onwards, and use that also as this kind of a verification of participation. Emails are strongly discouraged. As I mentioned, it's much easier to do this over Piazza. But if you do want to put it, then please have a header with the course number there so that I'll be able to find it within all the other emails that are there. So there's a lot of available resources as well, and that you can use. So again, you don't have access to this currently because it's not yet published. Canvas is not published, but as soon as it's going to be published, this will be the thing on top where you can use the syllabus. Any questions on the logistics itself? Great, fantastic. So it's pretty long. It's about 3 pages, but most of it is standard stuff, I would assume. I don't think there's anything apart from this. I don't think there's anything that is completely different from any other course that you would have taken. Yes. Can you repeat that? Sorry. For now, so I think we'll have more details later down the line in 2 weeks' time. The reason being that if we get access to those clusters, we need to increase the size of the group itself because we won't have as much access to clusters and stuff like that. So I don't have a clear answer for you right now. In 2-3 weeks time, I think 2 weeks time, I think I'll have a better answer for you. Any other questions? All right. If not, then there's also going to be a topical outline that is going to exist within the syllabus. So this is more like a dream, like an ideal thing where all of this we should be able to cover. But based on previous experiences, it's not been easy to cover everything, especially as and when we come to the very end. It's not always easy to go through everything that exists. For instance, explainability in AI, it looks as if this should be like 3-4 lectures based on how much everything is before, but we haven't been able to have more than like more than two lectures on the same thing with active learning. And each of these things, if we go through it, needs to be a lecture by itself. Anomaly detection, self-supervised learning, generative modeling, which is essentially what you see in your large language models, sequence modeling, and so on. So the goal of the course is the fundamentals of machine learning. That essentially means that we will go through things like classification, some algorithms like nearest neighbors, logistic regression. If the words I'm saying does not make sense, it's perfectly fine because we don't expect you to know these things. This is the goal of the course, which is to actually go through what is the meaning of these things like nearest neighbors and so on. But we will spend a substantial amount of time on the classification algorithms and what is classification in general. And we'll have specific homeworks for classification with respect to this kind of exercises on Colab. Same thing with regression, same thing with clustering, and so on. So these three are like the fundamental basic aspects of machine learning, or maybe I shouldn't say the basic aspects of machine learning. It's the best way to introduce machine learning is via these three applications, which is classification, regression, and clustering. In fact, if you have taken some other fundamental machine learning courses, or maybe linear algebra courses as well, the first thing you probably will learn is about regression, because that provides the easiest access into machine learning from a mathematical perspective. But from an application perspective, it's not as um, intuitive as something like classification. Because whenever we think of an algorithm, whenever we think of the practical application of AI, we think of it from an application of classification perspective. For instance, if you have like, I don't know, like Amazon app, for instance, and you have an object in front of you, you want to buy that object, you take a photograph of that object. And what the AI algorithm has to do here is to recognize that particular object or classify that particular object and use that to put it into your cart. It's more intuitive. Classification is a more intuitive application that helps us understand machine learning. So we'll go through classification first within the entire structure of the course. Once we are done with the classification, then we'll move on to regression. Again, if you are not familiar with the words, perfectly fine. Just let this wash over you, essentially. When we come to this, you'll have a better understanding of what I'll be telling at the time. But regression is essentially not just a single number that is given, it's just a sequence of numbers. So there's no discretization that happens in this kind of regression. Last one is clustering. If ever you watch Netflix and there's kind of a recommendation system that is going on, it's doing these kind of clustering algorithms along with the regression algorithms to give you results. Now, the big revolution that happened within machine learning was the introduction of this neural networks. You might assume that this happened in 2011 because that is when everybody started talking about neural networks and deep learning. But neural networks came, the first neural networks was back in like 1960s, the way we understand neural networks. Since then, there was small amounts of progress that happened. And once your transistors and your hardware capabilities and your big data capabilities exceeded what was there before, there was this huge revolution that happened in 2011 where you have models, machine learning models that instead of having like 1,000 parameters, now had like 65 million parameters. And using them, you had a huge increase in results. So we'll discuss, I would say, about 1/3 of the course is going to be about neural networks themselves, trying to understand what neural networks are, the basics of neural networks, and then building off of those neural networks in order to do more difficult architectures, like something like autoencoders, and then using it to have more difficult applications, which is going to be transfer learning, data augmentation, bootstrapping, and the topics below here as well. All these are applications within deep learning modules um, that are currently very essential to try to understand the layout of machine learning that is happening in research today. We'll also spend a substantial amount of time, or as much as possible, in trying to explain these AI modules, explain these machine learning modules, because as I mentioned, we moved from 1,000 parameter models to millions, and currently GPT-4 is like 1.76 trillion parameters. It's not easy to understand this kind of huge modules that are out there. So we need a substantial amount of time trying to explain these neural networks, and we are going to spend some time on trying to explain these things. So that should cover the entirety of the semester. The first 1/3 we'll discuss about classification, regression, and clustering, just a basic understanding of machine learning and how the layout was before 2011. Then we'll jump, the next 1/3 of the course is going to be about neural networks, autoencoders, and some kind of practical operations, while the last 1/3 will be about explainability, active learning. Active learning is kind of an application within the last one, anomaly detection, self-supervised learning, and so on. So that is going to be like the big three topics that we're going to cover. Again, if most of the words I said did not make sense, it's perfectly fine. Just think about it as 3/3, like 1/3 of this, 1/3 of that, and the last 1/3 is going to be different applications. Any questions about the course layout, about the topics themselves? And if anyone has any suggestions that you want to learn about, I'll be more than happy to include. For instance, reinforcement learning is something that is that is really good, and that's probably the best way to think of machine learning, what it's going to be in the future, especially from a robotics perspective. If you've heard of AlphaGo, which was DeepMind's chess engine, essentially, everything was based on this idea of reinforcement learning and so on. So if you are interested in certain topics, then please let me know. I'll try to see how much is possible to include those topics as well. As long as they have some kind of a relevance to what we are discussing, I'll be more than happy to include those topics as well. Okay. All right, so that is the end of the syllabus that is there. So this should be like the end of part 1 that we'll discuss for today. Any questions regarding this particular document? All right, you should be able to see this in either tonight or latest by tomorrow night when Canvas is going to be published. Let me try to go back to this one. I think in the slides as well, I have these kind of things. So yeah, I do have a few slides on Piazza and Colab. Hopefully everybody has used Piazza before, but the thing is very intuitive. Posting it, looking through the solutions, and trying to find what you want is pretty straightforward. But if you are ever if you doubt how to do it, you can come back to the slides. They're going to be posted online and see what they are. Colab as well. There's a good tool. There's a good resource, essentially, this one, to use Colab. When you will see, when the slides will be posted, you'll be able to go through and see these resources and links, essentially. Again, we'll see at the end of next week if we require an in-person tutorial regarding Colab based on the answers that you give. But essentially, if not, there is this kind of a review that I have in these particular slides that you can use. I don't think I'll go through the review today. We don't have time enough to do a review of these things for now, but it's something that we can have later next week if required. Online, by the way, there's a lot of resources, a lot of good resources to try to understand these kind of environments like Colab. And the best way is not to listen to someone. The best way is to just go in and just type and see what is working and what is not working for you. Go on Stack Overflow, go on all these other things that exist, and try to find the solutions for this, because environment is not something that is taught. Environments are something that you must have a hands-on experience. Otherwise, programming is it's really hard to get just by listening to someone. All right. There's also in the slides as well, I have other things as well. So I did mention that there are standard libraries that we're going to use. These are some of the standard libraries that we will be using throughout the course. That is in your homeworks. If ever you want to import matplotlib, please go ahead and do it, because it's something that we want you to do. So same thing with sklearn, scipy, pandas. All these pandas is basically some kind of data structure. So if you don't know data structures as good as like a CS student would, it's perfectly fine to use something like pandas. You don't need to define your own data structures or anything. Just use pandas, just use whatever's out there to get your results. Let's not reinvent the wheel. The goal is just to try to understand the machine learning modules rather than trying to implement everything that exists out there. So if you have, so in fact, I don't know if you remember, but we have like this kind of a nearest neighbors or k-means clustering words that was there. Those are like very hefty algorithms, but they're literally just a single command, single function within scipy and sklearn. So you'll be able to use all those things within your framework. There might be a few questions where you have to answer specific things about the algorithms, but if in your project, if you want to use these things, you're more than welcome to just take existing modules that are out there and use them within the framework in order to get a good result. There's going to be many video links, as I mentioned, about like Colab and all these Python packages that we'll be using. Again, you'll have access to all these resources. Um, so that is about part one, which is about the logistics of everything that happened. The next one is going to be, as I mentioned, just an umbrella overview of AI and machine learning in general. So let's start off with the bigger concept. I like to think of these as like these Russian dolls, where you keep removing one by one, and once you remove AI, you'll see ML. Once you remove that, you'll see deep learning, and so on. So that's why we'll start off with the topmost one, which is going to be artificial intelligence. Now, the way we understand artificial intelligence is, I don't think there's a single definition of what AI is, of what artificial intelligence is. The best way to see what AI is by actually looking at some examples. ChatGPT is certainly one AI example, but when I was first introduced into AI, it was only about search. Like Google, for instance, had all this search capabilities that was exceptional, that is exceptional, sorry. And the way it does it is by having this kind of an artificial intelligence framework that is able to retrieve the required information at the best possible time with the least amount of time. So that is one example of artificial intelligence. Maps is another one example of artificial intelligence. Sorry, I'm trying to find my cursor. Uh, oh. Okay, this works. So Maps is one example. So is your Nest thermometer, Netflix, your recommendation system within your Netflix. If you just see one show, Netflix starts recommending multiple shows. Now, there's a little bit of capitalism involved over there. They want to make sure that you keep on seeing as much as possible. So they try to push some unnecessary shows as well, which is fine. They are making money, but essentially they have a recommendation engine within, which is based on these kind of AI algorithms that is giving you some good recommendations and results. Siri, if you have used Siri, also a form of AI that we're using. The goal here of what I'm saying is that there's no one good application of AI that if I tell you, look at this, just seeing this, you'll understand what AI is. There's nothing that exists like that. Anything that is essentially trying to mimic human beings, you would classify as AI. Now, that by itself is just one definition, because here I have about like 3-4 definitions of what AI is, none of which are accurate. In fact, my favorite one is the second one here. Artificial intelligence, sometimes called machine intelligence or computational intelligence, is intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans. So it's just saying that it's artificial, that's it, not natural. And even though that's the most redundant statement and definition to make, it's probably the most correct thing, because it's the thing that covers the entire umbrella. Any single definition can be covered by this definition here, which is the second one, which is that it's simply something that is not human, that is artificial. If you want to get all philosophical and esoteric, you might then ask, what is the difference between a human and a robot? And in that case, there's so many movies that try to tackle that particular statement. Those are something that you could be referred to. But my point here is that it's not easy to define AI. And there's different ways that you can define AI. The same person, if you ask that person at 3 different points in a single day, they'll define it differently. Same thing with having multiple people define what AI is as well. It is not an easy thing to define. Look at the third one here. AI is often used to describe machines that mimic cognitive functions that humans associated with the mind, such as learning and problem solving. So again, when you try to define something, right, you're trying to assign properties to something. So if I were to say that AI has the following properties, which is that it is able to learn and it is able to solve problems, then that covers definition number 3 over here. So the second one was doing this kind of a semantic definition. The third one is doing this kind of a property-based definition. And you can then start going down the list. Okay, how can I start defining these things? And in fact, you can have books written based on just how to define certain aspects. And AI is probably up there as the number of definitions that are possible within the thing. So with that in mind, what is important for us? This is 1 semester long course. I can't just spend the entirety just going through the semantics of just 2 words, which is artificial and intelligence, essentially. So we have to have our own interpretation that we need to use throughout the course. And for that, we'll basically be looking at the third statement here, which is that humans should still be part of the process. Now, where they are, we don't know. It could be the third definition, for instance, is that learning and problem solving is something that human beings do. Cognition is something that human beings have. So because these are the properties that human beings have, that is important for artificial intelligence. So anything where human beings are a part of the process is going to be artificial intelligence. Again, this is a very narrow view of what AI is, but that is the definition we'll be sticking to, because that is going to help us in the future when we look at what machine learning is, because machine learning, again, is dependent on human beings who are doing the actual learning or who are helping along the actual learning. So the most important differences between artificial intelligence and natural intelligence, I don't know if this is visible. Oh, okay. Maybe the color scheme is something that I should change in my slides. It's good in the screen here, but apparently not. This is speed, bias, and accuracy. I'm not sure if you're able to see it, but essentially AI-driven algorithms, they have a higher speed of execution. Let's take a simple calculator, for instance. You can multiply very large numbers and get some very quick results. AI algorithms essentially are doing these calculations. They're doing a bunch of multiplications. We'll see this down the course in the second 1/3, which is the neural networks. All they're doing is a bunch of calculations, millions, trillions of calculations, in fact, in order to get some output. And they're able to do it very, very, very quickly. But the problem, of course, is the accuracy part of it. They're only accurate in a few things, while they're not accurate in other things. From a calculator perspective, they outsmarted us a long time back. Simple calculators are much, much, much better than humans in terms of actual calculations. Even from a perception perspective, it's able to take 200 different breeds of dogs, and it can pinpoint and say that this, given a certain image, this is the breed of dog that exists. Human beings are not able to do it, at least general human beings. If you bring like 200 normal people who are not dog enthusiasts, if you bring them and show them some very like a rare species of dogs, it'll be very difficult for them to identify. But AI algorithms, neural networks, can do that quite well. But there are other things, reasoning thing, where it's very hard for AI algorithms to do. There's this one example for ChatGPT called the Snow White problem. I don't know how many of you have heard about it, but essentially someone asked the question, which was the first animated movie? And ChatGPT said that the answer is Snow White because it was released in 1930s or something. But then there was this Argentinian movie that was released about like 5 to 10 years before Snow White, and that should have been the answer. Now you can say that maybe ChatGPT did not know this, did not know that the answer was this Argentinian movie. But then when you directly prompted it and asked, I should have known the name of this movie, but I don't on the top of my head. But this, if they ask, what do you know about this particular movie? ChatGPT said that it is an animated movie that was released about 10 years before Snow White. So it knew the fact that this movie existed, but it could not resolve that the year, I don't know, 1925 was lesser than the year 1935. So the answer of the original question, which was that the first animated movie, which was the first animated movie, ChatGPT was not able to resolve and answer that question, even though it had knowledge. So the thing is that even though it's able to accurately retrieve information, it cannot reason about this information. One of the biggest problems that AI is facing right now is this idea of reasoning. It cannot assimilate the knowledge that it has within this 1.76 trillion parameters that exist. Again, these are research questions that every day the answers are coming out, and people are trying to answer these questions and are doing a very good job of answering these questions and making AI better and better. But still, there is a huge amount of work to be done, of research to be accomplished. The last one is bias. And this is, so speed, AI is extremely good at it. Accuracy, it's very spotty. In some places, it's very good, while in other places, it is very bad. Bias is a clear case of bad. Because of the fact that AI cannot reason about something, it just looks at the simplest features in order to make some kind of decisions. And that can be extremely problematic. If you take a huge data set of, I think there was a police data set a few years back, which they tried to classify or say these are the human beings who are most likely. I mean, this is like Minority Report, essentially, where they were trying to, the movie Minority Report, where they're trying to do something similar. And AI could not resolve at all, looking past certain very simple features that it should not look at. So it's extremely biased. And you can argue that the problem is not the AI itself, but rather the fact that the data set is structured this way, which is absolutely correct. It's learning and data structure is structured in a way that it is making it quite biased. And that is, again, another area of research where we have to go through and make a better AI module, essentially, in this setting. So there are, of course, major differences between AI and natural intelligence, but the newest AI track or research is about something called AI alignment, where AI and human beings must, their decision making must align with each other. So ChatGPT is by the company OpenAI. If you look at OpenAI, if you open their website and you look at what they're doing, one of their key things that they've mentioned right now, since I guess the last 2 years, is about this idea of alignment between AI algorithms and machine learning modules, which basically means that the way human beings reason about something, AI also should reason about it in a very similar fashion. And again, not to harp on the same thing, but reinforcement learning is something that they say is the way to go forward about it, which makes a lot of sense. So from a perception point of view, if you look at the figure on the right-hand side over here, this is actually a bunch of blueberry muffins and puppies that are superimposed next to each other, everything. And the reason it's being put here is that somebody did this, I think, back in 2017, and a neural network it was very hard, even though the network beat a human being in like general categories. It was not able to resolve between a puppy and a blueberry muffin. Now, even for us, sometimes looking at it at first glance, it might be very tough. But once you look at it, once you reflect on it, once you introspect on it, it becomes much easier. I saw a post recently actually where they showed this image now to ChatGPT and it was able to correctly classify. And the tagline was something like, "Oh, perception solved," which is not true, of course. It's just that this particular image is now part of the training set rather than being part of the test set. But it's the best laid plans of sensors and networks, and they often go happy basically. So it's not easy for AI algorithms to perform their best in these situations where there's a fine grained difference between things that exist in these cases. Okay, so in terms of what we'll be doing within the course itself, we need to think of it as three separate things. We need to think of we have data. We need to represent that data in a manner that is good for an AI algorithm. Now, the AI algorithm is the middle portion, which is going to extract these kind of features that are important for some kind of analysis framework. And the analysis framework is that given some kind of data, we should be making some suggestions, some kind of output, some kind of decisions on that data in order to get these kind of results. So we can think of it as three separate stages, which is a visual representation, feature extraction, and feature analysis. In the first 1/3 of the course, this is going to be extremely important. We'll be thinking about the entire machine learning pipeline as three separate stages, and all of them are very, very important. If we don't have a good representation, then we are not going to get a good extraction. If we don't have a good extraction, there's nothing we can analyze on top of. So the entire framework falls flat because one of these modules is not correct. Now, what deep learning did was it actually connected all these things. Instead of having all of them separately, it said that a model can learn by itself what the best representation is, what the best extraction is, what the best analysis is. And that's one reason why it works very well on a given task, but it kind of combined these three modules by itself. So going back to the question of what is artificial intelligence, we can think of it as from a knowledge perspective. So any artificial intelligence model, whether it's a machine learning model, something else, has these kinds of knowledge attached to it. There's this kind of an explicit knowledge, implicit knowledge, and there's a tacit knowledge, essentially. And all of them are very different, but extremely important for the functioning of an AI module. So explicit knowledge is something that is easy to articulate, write down, and share. This is something that AI algorithms currently excel in. So give them a certain facts, tell them to memorize it. They do them extremely well. They can tell you what the state capital of Georgia is quite easily, because this is knowledge that they don't need to reason about. This is knowledge that is given to them, and all they need to do is remember. And again, from a very esoteric perspective, if we think of how human beings learn stuff, this is how we learn, right? In grade school, for instance, we were not asked to do induction or calculus or something like that. All we were asked to do was just learn these things and store that information, essentially. And then when we were given exams, we used to have these kind of questions. What is the state capital? And you used to write the answer there. That would be the answer in this particular case as well. So AI would do a very good job in terms of explicit knowledge. The next one is implicit knowledge, which is the application of explicit knowledge. And I would argue that currently, most of the work that is happening, if you read literature, in terms of if you read papers that come out for the last 3 to 4 years, people have moved past trying to have good explicit knowledge, because AI modules already have good explicit knowledge. They are now trying to use this in terms of implicit knowledge. So what that basically means is that you're applying some knowledge that you already have. A network or a AI module has learned something. You need to use that knowledge in some other fashion, in some other task, in some other application. And we'll discuss somewhere in the middle of the course something called transfer learning and these other kind of applications, meta learning and transfer learning, where machine learning modules are doing exactly this. They're taking something that has been learned in one context and using it in a completely separate context in order to get this implicit knowledge. The last one is um, and there's no good work that has gone on yet, which is learning from personal experience that is more difficult to express. Um, in 2022, the conference called Neurips, which is probably one of the best AI conferences out there. One of the, how do I say, if you know Jeffrey Hinton, he was one of the first persons to talk about neural networks and think about how they are one of the better ways of trying to do deep learning. So what Jeffrey Hinton said was that there will come a time when you can't simply erase a neural network module. You can't just run it once, then stop it and close the program because it has gained a certain amount of experience within that one session of you running a code. It has to be something that has to be embedded within hardware. So every single code you run should be embedded somewhere instead of just thinking of it as a software thing that is going back. The reason being that it needs this kind of person experience. It needs this time in order to try to understand what is happening. The last knowledge is not something that a network knows currently, and it's actually even very difficult to try to understand how to get this particular knowledge because it's difficult to express. So think about what it means to difficult to transfer to another person by means of writing it down or verbalizing it. What it means for swimming, reading, speaking, face recognition when it comes to AI modules. This is not something that currently even we can think of to try to answer these things. So with that in mind, with that which is AI, now we move on to a more simple, actually, I shouldn't say that. We move on to a smaller subset of artificial intelligence, which is machine learning. And that machine learning is essentially what we'll be doing throughout this course. So ML is a subset of artificial intelligence. As I said, it's like Russian dolls. You remove one, you have another doll within. And in this case, you've removed AI, and now what you're seeing is machine learning. Before we had search algorithms, now search is just a basic introduction into AI. When we have more courses with AI, it's mostly about machine learning modules. So ML modules basically build this kind of a mathematical model based on sample data. These are known as training data, essentially, in order to make predictions or decisions without being explicitly programmed to perform the task. What do I mean by the last statement here? There's no for loop, there's no if statement, else statement that exists within your module, machine learning module, because that is something that existed throughout AI, rule-based AI beforehand. You had these for loops, you had if statements, you had these search algorithms, all of them made up artificial intelligence. But what machine learning does is it removes that part completely. There's no rule-based system that goes on. There's no programming in terms of saying that if this happens, this other thing needs to happen. That part does not exist within machine learning. Everything is just a mathematical model based on sample data. And that's very important. You need this kind of a sample data that we'll be calling training data from now on for these kind of machine learning modules. The last portion here, based on empirical results, I have put this here, which is that it is superior to rule-based AI. But there is a vast community out there that is going to vehemently disagree with the statement. Rule-based AI, logic AI is still, there is a large number of researchers who are working on this. And if you take their courses, this is they'd say that it's rule-based AI is supposed to be how it is going to go, or logic-based programming is how it is going to go. And I think there is merit to those arguments because, as I said, we need to spend a substantial portion of the course talking about explainability of these deep learning modules. Even now, right? Like you use any large language models out there, they hallucinate and give you like completely incorrect results. Those kind of results is not going to happen when you have these rule-based AI systems. So when in safety critical applications like healthcare, for instance, maybe rule-based AI is the way to go forward. Maybe you need those kind of simple methodologies, simple rule-based methodologies in order to get good solutions. But again, it's from an empirical perspective currently, machine learning modules are extremely good in terms of how they show their results. So let's show a very simple, let me show you in the next few slides, I'll show a very simple machine learning model and what you can expect out of a machine learning model. So let's say Netflix has this recommendation system problem. You have 4 people. All of these people have watched these movies: Interstellar, Toy Story, Russia, Gravity, and Curious George. And the goal, Netflix usually asks you, okay, how good did you find this particular movie? If you find it very well, then it's a 5. If you don't like it as much, maybe rate it as a 1. And that's what people do. Let's say each of the person, let's say Ahmed, starts with watching Interstellar. He loves it a lot, so he gives about a 5 for it. But Ahmed has not watched Toy Story, which is a travesty. Actually, it's pretty good. But Gravity, I'm not as sold on that movie. Rashad is pretty good as well. So he gives these ratings for these movies. Same thing with Chen. The question mark essentially is that this person has not watched this particular movie. So this is kind of a matrix that we can derive based on the person as well as the movie that exists and how much they rate it. The question for us from a machine learning engineer point of view is, how can we translate this problem to a computer? And the goal for us is, let's say I'm now given a 6th movie, I don't know, which Interstellar, what is that dream movie, Inception. Yeah, Inception. So if Inception is the movie, if what would Ahmed rate Inception? What would Chen rate Inception? Susan or Kiran, how much would they rate Inception? Is the question that a machine learning algorithm needs to answer. But it needs to, it's not just a simple guess. Just because Christopher Nolan has directed that movie, it shouldn't be that Inception is going to be 5200. It has to be something that is based on all 5 movies combined. And this is very important. That is how machine learning modules need to work, essentially. The way we think about it is a very mathematical processing. Again, as I mentioned before, there's 2 big mathematical frameworks that we need to think about. One is a linear algebra point of view, another is a probability point of view. In this particular example, I'm showing linear algebra, but there is a probability way of looking at it. In fact, next lecture, it's all going to be about probability. You can think of this matrix as a combination of 2 the rows and columns. If you take the features, if you derive some kind of features, let's say Laugh is essentially, it's a comedy movie. So Russia is a comedy movie in this particular case. Toy Story is also kind of a comedy movie as well. So essentially, you'll be able to derive these kind of features out of your movies and put them as your columns. You're replacing your movies based on these features here. And this is very important. We are defining these features as a comedy, as some kind of a sci-fi movie or an animated movie, and we are using that as our features. This is where the handcrafted part comes in. We'll talk about that a little bit, but you can use that features in the columns as well as the rows, essentially. And once you have that, you'll be able to have some kind of a mathematical module, simple mathematical definition that goes through and gives you this kind of a n result. Again, what I just mentioned here is, this is not a machine learning way of doing it, because I went in and said that there are 3 genres of this movie, which is it could be a comedy, it could be a sci-fi, or it could be an animated movie. I am making this decision. So this is more of a rule-based system rather than an ML system, if I do it from this perspective. But if I were to just define some module without actually saying that this is a comedy, this is a sci-fi or an animated movie, then it would be a machine learning module. So those features are something that is not going to be defined by me, but is going to be defined by the module itself based on this algorithm. N is equal to NL into NR, and you kind of optimize this. Try to say, okay, can you cluster all these movies together and see what the results are going to be? Yes. Oh, sorry. Maybe that's an incorrect thing on my part. So this, if you're asking, we take the same feature in order to define both the things. So if I let's take the NL matrix here. I can take 5 movie genres and say that this movie belongs to a comedy, sci-fi, or an animated movie. And if I take the features on the row side, I can say that Ahmed and Chen are more interested in sci-fi movies, while Chen and Kiran are more interested in comedy movies. So the same set of features can exist for both the rows and the columns as well. It's just that you are moving from one space into a completely different representation space that you are defining. So based on that, there's multiple questions and multiple things that we can do, right? One of them is that even though Susan and Kiran have not watched Interstellar, the fact that they have watched Gravity basically means that you can use that as a way of saying, okay, if they had watched Interstellar, maybe Susan would have said that this was a 3. If Kiran had watched Interstellar, maybe he would have said that Interstellar was a 4, based on the fact that this is the thing that they gave for Gravity, based on Toy Story, Rush Hour, and so on, depending, of course, on the comedy aspect of Interstellar plus the sci-fi aspect and so on. So this is something that could be done. So that was more of a like an how do I say it? Like a very big picture way of defining what machine learning model can do for you. A more simple example is something like digit recognition. Okay, given let's say in my training data, my sample data, I have 7 to 1, I have all digits, and this is what those digits look like. And during test time, I'm given this particular digit. This was a data set. This is a data set called MNIST that was there since the 1990s, essentially. What happened then was they took the post office digits that was there in the mail. They took photographs of that, and this is the resultant of the photographs, essentially. This is the photographs of those digits from post. So given this image, what is it? Is it a 5? Is it a 6? Is it something else? Is the question that an ML model has to answer for us. So given this huge data set on the right-hand side here, there's 70,000 small images of handwritten digits, image size like 28 cross 28. By this, it means pixels. There's 28 pixels in the rows and 28 pixels column-wise, and each image is labeled with the digit it represents. So what we do, of course, is we can do 3 kinds of things here. Now we're going into the weeds of what machine learning is, which is it could be either something like a supervised learning, unsupervised learning, and reinforcement learning. Again, we'll have entire lectures that are dedicated to these things. Today's goal is just to become familiar with a few words, essentially, and we'll be seeing more of this throughout the course. Supervised learning is essentially requires labeled training data. This is one of the biggest fallacies in machine learning and deep learning. When you ask a person who has not worked as much with these modules, is the first thing that they would say is that these kind of deep learning models require a huge amount of data. It's not the deep learning or machine learning model that requires it. It's just one aspect of machine learning, which is supervised learning, which requires a huge amount of labeled training data. And it's very easy to get this when we look at like natural images, but as soon as you come to like healthcare images, for instance, seismic images, it's not easy to get all these kind of labeled images. In such cases, maybe supervised learning then is not a good way of doing it. Maybe we need something like unsupervised learning, where there's no label requirement at all. Or we can do reinforcement learning, where you're just given a reward for doing something correctly, while you're punished for doing something incorrectly. So there's different ways based on the constraints that you have, based on either the data or the module or something else, in order to get these kind of different machine learning modules. So let's go through the first one, which is supervised learning. Given this kind of 70,000 images, you divide it into 2 halves. You divide, not halves, you take 60,000 images as training set, 10,000 images as test set. So 60,000 images, you train based on all these images and see what the results are for the remaining 10,000. That would be a supervised learning setup. Unsupervised learning setup is you don't have access to this kind of labels for these 60,000 images. So you would have to cluster and say that, okay, all these zeros look alike, all these images of zeros look alike, and they're very different from ones. So obviously, these two are separate classes. They're not from the same class. This is this kind of intuition that you need to have regarding the data, and then form this kind of clustering and use what we would call an unsupervised learning module. reinforcement learning, it's really hard to use MNIST dataset to give you an idea of what reinforcement learning is. A better solution there is actually chess, where your reinforcement learning, you start moving your pawn from, let's say, your I don't know, e5. That would be your first thing. Let's say your first pawn movement was actually in a completely separate thing, like h8 or something like that. It moves from that position. Every single time it loses, let's say if it moves a particular pawn from a different position, then it realizes, okay, maybe this is not a position that I want to move. I always need to go to e5. And it starts learning this, right? So this is how reinforcement learning works, where it makes something, it makes a move, realizes it's bad, and then corrects itself. So you don't have a output, you don't have labeled data. It's just that you have n number of simulations, infinite amount of simulations that it can use in order to get a good result. So that would be a case of reinforcement learning. And from this, we have, as I mentioned in the topic overview, we'll have different applications. We'll have different tasks: regression, classification, clustering, and dimensionality reduction. Regression is predicting a value based on independent variable. Again, this is not something we want to tackle right now. We'll first tackle classification, which is identify to which of a set of categories a new observation belongs. So given this image of a 5, and given all this training data, maybe this looks more similar to this 5 over here. So, it belongs to a 5. That is what classification is doing. Clustering is the unsupervised thing I mentioned before, which is given all zeros, just clustering all these zeros together, you're clustering all the ones together, and so on. So you basically divide the data points into a number of groups, clusters, such that data points in the same group are more similar to each other than other data points, essentially. The last one is dimensionality reductions. Reduce the number of random variables based on some components. Again, this is not something we can tackle in first lecture itself. Essentially, what it is telling us is that if I go back to this slide here, oops. Maybe the three things that we showed before, which is the comedy, sci-fi, and animated. Maybe you don't need all three categorizations. Maybe you only need the comedy and sci-fi. Animated is something, it's a feature that is not required within the entire framework. Just based on it being a comedy or a sci-fi movie, I should be able to give you a good result later on down the line without having to use animated feature at all. That is basically what the dimensionality reduction is telling us. But again, we'll discuss all those things in the latter half of the, I would say middle of February is when we'll discuss about dimensionality reduction and so on. I don't know how much time I have in order to complete the deep learning portion of the introduction part, but essentially, machine learning. So we discussed creating these kind of features for handcrafted features, and then you have machine learning, which is the supervised learning, unsupervised clustering, dimensionality reduction. But then there's this huge component, which is deep learning. The difference between traditional machine learning and deep learning is that the three stages, which is the representation, extraction, analysis, does not exist within deep learning, or does not exist independently in deep learning. The same network does everything. And there is a very good reason for doing this, because this is essentially how our system, human visual system, works as well, how our brain functions as well. Our retina to LGB cells, simple, then complex cells, lower order hypercomplex cells, and so on. All these processes are happening within the brain and within the human visual system. There's no differentiation. There's no these particular set of cells are going to do, the first 5 set of cells are going to do X feature representation. The next 10 set of cells are going to do Y feature extraction. That differentiation is not there within the human visual system itself. It's all just a conglomerate, mixed processes that are happening within the system. And one of the motivating factors of even naming them neural network is this idea that we are trying to imitate human beings. We are trying to imitate the brain of human beings. So there is a lot of work out there that does this kind of neuroscience related computation. And we won't go into details regarding this throughout the course. It's just something to be, it's just something to know that there is a reason that we are doing that. We have moved from rule-based machine learning to this kind of deep learning-based system, and it's a good reason essentially. So what is deep learning? Again, going back to the Russian dolls, we did AI, we did ML, and now it's DL, which is deep learning. Essentially, what deep learning is doing is, given a set of input pixels, it's just extracting features, which is the edges, corners, contours, object parts, and then doing this kind of an identity. Is this an image of a person or a car or an animal? And seeing all the features within, it becomes quite easy for a deep learning module now to see what this object is in this particular case. I'll probably skip this slide. Again, as I mentioned before, in the beginning, it was very simple. In the year 2012, it's about 65 million parameters were there for this particular module. It was called AlexNet at the time. Right now, in 2023, last year, GPT-4 came out with 1.76 trillion parameters. So there has been an increasing model sizes. I do expect that this is one of the larger things, because research these days has tried to reduce the amount of parameters, because it is not easy to train 1.76 trillion parameters. You need to use thousands, millions of dollars, and the cost it takes in terms of the energy as well is extremely high. And it's not something that anybody and everybody can do. So the research these days is in decreasing this particular size, but still, it's extremely high at this moment. Even the error rate itself. So till 2011, it was not deep learning based models. It was more machine learning based models. Your error rate, classification error, was very high on this, a very important classification task data set called ImageNet. You had 28% error, 26% error. If you asked a human being, if you showed images from this data set, this is that of a steel drum, right? And there are like a million such images. If you showed human beings this, they usually have an error rate of 2.5%, or sorry, 5%. Human error rate is 5%. So among million images, they are able to identify 995,000 images or something like that correctly. Non-deep learning models were able to classify about 62%, 72% correctly, or 74% correctly. As soon as you have deep learning that came in 2012, that decreased. In 2015 and 2016, the error rate is actually less than humans. So deep learning modules are better than humans in this particular task of identifying among 1,000 categories on 1.4 million images. Deep learning is actually better in doing that than human beings. So there has been a historical trend in moving towards a better result. So this is more the trend that has happened. So before, we used to have inputs and then hand design program. This is the FL statement. This is the comedy, sci-fi, and thing that, the features that we have designed ourselves, and then we would get an output in this particular case. Machine learning models takes the hand design features and then does an implicit mapping between features and the result. You have that NL multiplied by NR, I believe it was, and then you have an optimization framework that helps us deriving what those weights are. But still, you have those hand design features within the ML framework. DL removes that hand design features, and it says that, okay, instead of having these hand design features, I'll have simple features like edges, and then I'll have more abstract features like I think it was colors and contours in this particular slide, and then even more abstract features, which is object parts, before I finally identify and give you an output of what the resultant is. So this is the difference between what a deep learning algorithm does with a result. So if I look back and if I take an umbrella approach, a view on everything, this is what a learning algorithm is doing. A machine learning algorithm is an algorithm that is able to learn from data. This is like a very simple and a good definition of machine learning. Given a module, I can learn its parameters. You start off with, and what I mean by that is it's just a set of numbers at the end of the day that you start off with. What is the ideal set of numbers? What is the ideal weightage I give to Interstellar? I give to, what was the other ones, like Curious George, in order to get a good recommendation. right? What is the ideal set of weights? That is something a machine learning model, instead of me saying that interstellar is more important than Curious George, a machine learning model is going to detect that for you based on a large amount of data. So essentially what machine learning is doing is exactly what a computer program is doing as well. That is the goal of the last sentence is. It's just that instead of defining all these parameters, it is doing it in a way where it's learning from data to define parameters rather than someone coming in and doing the defining for them. I do have other slides as well with the deep learning framework, but I don't think they're as important. Let me, oops. The last part of this, I think, was something that was what I wanted to talk about, which is the idea, just to try to understand deep learning from a myths perspective. We usually have an expectation of what AI and deep learning is, but when you actually start looking at it, it's going to be very different. There are about 6 slides where I'll talk about like common myths about deep learning. I don't know if we'll have time to do this next class, but I'll try to do this next class. If not, this is something that we'll bring back during the latter half of the course when we discuss more about deep learning in general. But that is the end of this lecture number 1. Let me stop recording and stop sharing.